The question says if the electronic structure of oxygen atom is written as, you can see this is the electronic structure या orbital notation of oxygen atom given here. Okay, it would violate Hund's rule, Pauli exclusion principle, or both, or none of these. Okay, so orbital notation is given there, and from there we can check Hund's rule as well as Pauli exclusion principle also there. Pay attention carefully. In orbital notation we have, you can see these are the paired electrons. Okay, one is spin going upward direction, another is spin going downward direction. If we apply Pauli exclusion principle, it says no two electrons in an orbital, you can see this is one orbital, this is the second orbital, this is the third orbital. Okay, no two electrons in an orbital can have all the four quantum numbers same. All the four quantum numbers same. But now you can see in this case one spin going upward direction and another spin is going downward direction. So in this case we can say clockwise rotation, S value will be plus half, and in this case S value minus half will be there. So you can see it follows Pauli exclusion principle. Okay, Pauli exclusion principle is followed because one spin is showing different quantum number, spin quantum number value, and another spin is showing different quantum number value. And condition is what? No two electrons should have all the four quantum numbers same in an orbital. So it follows Pauli exclusion principle. Now we apply Hund's rule. In orbitals, filling of electrons is always done according to Hund's rule. What does Hund's rule say? It says that filling of orbitals is always done with single spin and then followed by double spin. Filling of orbitals is always done with the single spin followed by double spin. So you can see we have 2p are there, 2p orbital is there, 2p subcell we can say. In this case how many electrons are there? 4 electrons are there, 4 electrons. Okay, with that 4 electrons we have 4 electrons are there. Okay, electronic configuration for oxygen we have atomic number is 8. In this case we get 1s2, 2s2, and this is what 2p4 is there. Okay, one orbital fill these 2 electrons, only one orbital in S subcell, and but in P subcell we have 3 orbital is there. This is what px, py, and it is what pz is there. When we fill these electrons we follow Hund's rule, and according to Hund's rule filling of these orbital is done first single spin followed by double spin. How many total electrons are there? 4. Single spin, single spin, single spin. Okay, each orbital will be filled with single spin, then double, then one more extra electron are there. This is how we are supposed to fill. So if we follow Hund's rule, this is what we are supposed to get. This is the orbital notation we are supposed to get for oxygen, but it is not given here. You can see in the start, from the very beginning, they have start pairing of electron. They have started pairing of electron. In the starting, pairing of electron is not done. First single spin, then followed by double spin. Means it does not follow Hund's rule. It violates Hund's rule. Okay, this electronic configuration is correct. This is incorrect. If you like this video, please share and subscribe to the channel.